let's graph this piecewise defined function. So on this function, it's a little bit different than others you might see because instead of having intervals over here on the side, we basically just have two choices. Either the number we're plugging in is -3, which means we go with the second equation, or it's something other than -3, which means we go with the first equation. Now, if you're plugging in this first equation into your calculator to help you graph it, make sure that you put the top in parentheses and the bottom in parentheses with the division in between so that it'll do the order of operations correctly. And then we're going to graph things around -3 to get an idea. At -3, we're going to have an open dot. But let's see, at -6, we're at -9, so my graph's not actually big enough, but about right here. At -5, we're at -8. At -4, we're at -7. And then at -3, we have an error, which is why we're defining this piecewise, is so that we can kind of have some value here where the first function doesn't actually give us any value. -2, we're at -5. At -1, we're at -4. And we can keep going. So what's happening is that if you were even to look closer or look at your graph instead of at your table of values, this function looks like a line. The problem is that here at -3, where we think it would be -6, it isn't defined because if you plug a -3 into this function, it gives you a 0 on the bottom. So we're going to put an open dot right there where our error is, but otherwise draw our line to either side. And then at -3, we know that our function is going to be 2. So at -3, our function is 2. That's a point up here. And so that is our function defined piecewise. Now, this kind of graph is called discontinuous because you cannot draw this graph without picking up your pencil to draw the dot up here. And this kind of discontinuity is called a removable discontinuity. A removable discontinuity means that, well, if we could just fill this hole in, it would be continuous. So it's like if you could remove the hole, you'd be okay. A non-removable discontinuity would be where your graph jumps, like you're going here and then you do something else. Well, you can't just fix that by filling something in, like a vertical line, because that wouldn't give you a function. So that was actually extra information that wasn't necessarily needed. So